Do you feel puzzled when it comes to asynchronous programming and how that applies to your .NET applications? Do you want to build better performing applications and write code that doesn't lock up the application while it's waiting for data to be available? Solving this is often where you will first encounter asynchronous programming. Understanding this can be quite tricky and overwhelming. But don't worry, you are in good hands. Throughout this course, you will go from learning the basics to understanding how to best apply asynchronous programming in your .NET applications. No matter if you are new to C# or an experienced C# developer, you will definitely benefit from this course. My name is Philip Ekberg, and welcome to the course Asynchronous Programming in C#. All the patterns and principles covered throughout this course can be applied in any type of .NET application. This is the application we are going to improve throughout this course. It doesn't yet use any asynchronous principles, and our job is to make the application better by introducing ways to load the data without locking the user interface. The purpose of this application is to provide you with fake stock price information. If you search for a stock, you can see that the user experience is rather bad. The application freezes, and after a while, the operating system is even telling us that the application is no longer responding. Let's jump over to the code and find out why. This is a Windows application, but everything we talk about can be applied in any C# and .NET application. This application will make it easier to illustrate the benefits and importance of asynchronous programming. When the button in the application is pressed, the method search-click will be executed. This is the event handler for the click event. Some of the code in this method is considered legacy, but unfortunately, it's what a lot of us have to work with. The code uses a legacy code piece called the web client. The web client provides a way for us to synchronously go and download a string from a particular web API. Being synchronous means that it's going to run on the same thread that executes it. In our case, this method call originates from the same thread that manages the entire application graphical user interface, also known as the UI thread. This thread will be blocked until the synchronous call has completed. This means that we need a way to offload the work of loading that data to a different thread. And once the data has been properly loaded, we can go ahead and handle it. Let me quickly refactor the code and apply the asynchronous principles that you will learn all about throughout this course. Don't worry, we're going to cover everything that's going on here in greater detail throughout this entire course and apply everything step by step. With this refactored, the application now behaves a little bit differently. I can take notes as the data is being loaded. This is a big improvement to the user experience. The refactored and improved version of the application applies the asynchronous principles, which means that the heavy work of loading the data has been moved to a different thread. This will prevent the application from locking up and have a more responsive UI. When the data has been loaded, the code to handle it is notified and the UI can be updated accordingly. There's not really a big difference between the synchronous and asynchronous versions of the code. There are a few different classes and a few different keywords. Instead of using the old legacy web client, we are now introducing the class HTTP client, which provides a way to perform asynchronous operations to consume web resources. The HTTP client is used to get all the information for the stocks from a web API. We do so by calling the method getAsync, which will perform a web request against the URL that we've specified as its parameter. This here is an asynchronous operation. Calling this method means that the operation will occur asynchronously. Therefore, the UI thread is relieved of the work to download the data and can instead listen for additional UI interactions. Apart from calling getAsync, you can also see the async and await keywords being used in the code. Async is a way for you to indicate that this method will contain asynchronous operations. Await is a way to indicate that we want to come back to the code and execute everything after the await keyword only once the data is loaded from the API. We're going to master these keywords and how to use them appropriately and effectively throughout this entire course. The biggest reason for introducing asynchronous principles is to improve the user experience. It's also a way to write better performing applications, as you can proceed to execute other parts of the code while you wait for an asynchronous operation to complete. We saw this in action when the UI thread was relieved of heavy work and was able to listen for more user input. Asynchronous and parallel programming isn't really a new concept. Traditionally, we've had different ways of building multi-threaded and asynchronous code, with, for instance, the lower-level threading, or something like the background worker, which is an event-based asynchronous pattern. Nowadays, it's mostly common to use the task parallel library together with the async and await keywords. With minimum effort, this synchronous code that locked up the application and gave us a really bad user experience was refactored into an application that applies these asynchronous principles. This gives the user a much better experience. This here is just scratching the surface, but shows why it's important to learn how to properly apply the asynchronous principles. I just want to emphasize that async and await, as well as the task parallel library, is something that you can use in any different type of C# and .NET application. There's a lot that can go wrong if we don't properly understand how to apply these asynchronous principles. Proceed throughout this course to fully understand how it all works and fits together.